In our last topic, we looked at how we can analyse some of the light that's given off by stars, so how we could use those absorption and emission spectras to try and figure out what elements make up a star. In this video, we're going to have a little look at some calculations we can do that are going to tell us even more about stars, just by looking at the type of light they're given off. Now, for all of these calculations that we're going to do, we're going to be making an assumption. And that assumption is that all stars are what we call black body radiators. So they give off black body radiation, which means that this is an object that we assume that perfectly absorbs and then re-emits all the energy in it. So what that means is that what's emitted by a black body is purely dependent on its temperature. So the type of light that we see, the wavelengths of light that we see from a star, are only to do with the temperature that the star is at. So that means that there's a direct relationship between the temperature of a star and the wavelength of light that it gives off. And this leads us to Stefans Law. Basically, we assume that stars are perfect black bodies, then we can calculate the temperature. And the law that we use to do that says that the maximum wavelength that is given off multiplied by the temperature equals a constant. And that constant is 2.9 times 10 to the minus 3. It's just called Wien's constant. So basically, if I have two stars, if I know the wavelengths given off by both and the temperature of one, I can use that to figure out the temperature of the other. They will probably ask you to do that rather than give you Wien's constant to do it. So this is another one of those basically proportional relationships. All we are saying here is that we've got a proportional relationship between the maximum wavelength given out by the star and its temperature, and we can use that to figure out exactly what's going on. Okay, so basically we know the colour or the wavelength that gives off, that tells us the temperature of the star. So that's the first law, that's Wien's law. It's also called Wien's displacement law as well. So you might read it as both, it doesn't matter what you want to call it. Second law we need to look at is Stefans Law. And Stefans Law talks about luminosity. Luminosity is the total power emitted by a star, and we calculate it using the Stefan-Boltzmann law, or just Stefans Law. And that is given by L equals 4 pi r squared sigma t to the power of 4. So that is luminosity equals 4 pi times the radius of the star squared times the Stefan constant times the temperature of the star to the power of 4. So it's just sort of a pluggy-in thing. But luminosity is something that we can measure, so we can figure out how much energy it's giving off. And with Wien's law, by looking at the type of light given off, we could figure out the temperature. So if I can measure the luminosity directly, I can calculate the temperature using Wien's law. This then gives me an equation that will let me figure out the radius of a star. And that's going to be very, very useful in figuring out other things about it. Basically, if I combine these two laws, Wien's law and Stefan law, like I was just talking about, I can get the radius. Once I've got the radius, I can do all sorts of things. I could use Newton's law of gravitation to find its mass and therefore its density, which would let me figure out exactly what it's composed of. So these are very useful laws that have a lot of knock-on consequences. So that is radiation from stars and the calculations that we can do with it. So, got any questions? Just ask when you see me in class.